Hello, amazing psychology students, and welcome to Chapter 5, Identifying Good Measurements. What we're going to be covering this week is our chapter outline to your left and our learning objectives to your right. So for the chapter outline, we're going to be looking at ways to measure variables, reliability of measurement, are the scores consistent, validity of measurement, does it measure what it's supposed to measure, reviewing, interpreting, construct validity evidence, and our learning objectives are going to be to interrogate the construct validity of a study's measured variables, describe the kinds of evidence that support the construct validity of a measured variable. So let's get into it. So here you're looking at different ways of measures of variables. We have what we call variables and operational definitions. So can you really quantify how happy people are if we were to measure, say, the word happiness? So happiness is a construct, and it's hard to assess because you don't know exactly what happiness means, right? So we need a conceptual definition of the word happiness, right? So if we're looking at conceptual definition, it is the definition of a variable at a theoretical level. Conceptual definition of happiness is, in the case of a study, maybe we're going to say that it is subjective well-being. That's what happiness is. That's your conceptual definition. Your operational definition represents a researcher's specific decision about how to measure or manipulate the conceptual variable for their study. So now that we know, let's say happiness is the subjective well-being, that's our conceptual definition, we have to apply an operational definition to that, something that we can measure. So happiness, how we're going to do that is we're going to have people report on their own happiness in a questionnaire format. That way it can be measured. Maybe we're going to give them a Likert scale and measure on a scale of 1 to 5, how happy are you throughout the day? Very happy, so on, down to not happy at all kind of thing. So it has to be some sort of operational definition, something that can be measured. And if we were to do the study over, we can use the operational definition to help us then replicate the study. So different variables have different operational definitions. There's a list of different types of variables that are found in your guys' textbook, as well as in the first column what the variables' names are. Gender identity, wealth, one possible operational definition, so what we call operationalization. Let's say wealth. Wealth, one operational definition could be asking people, what is your total annual household income before taxes, right? It's measurable. You can tell what's the income. You're asking the question, right? Another possible way of doing an operational definition for wealth is maybe coding the value of one's car from 1 as being like an older car, lower status vehicle, to a 5 being like a new higher status vehicle in good condition. So your operational definitions are things that you can report out on that normally have numbers attached to them or that can be measurable. Okay. So if we're looking at 3 common types of measures, we have what we call the self-report measure, the observational measure, and the physiological measure. So your self-report measure is anything that you yourself are reporting on, right? So it's maybe things, measures that a variable through people asking questions or answering questions on a questionnaire. Or maybe you're giving an interview and you're being asked questions and the researcher's recording the answers. Maybe you're getting reports from parents about a child, personality tests. Those all classify as self-report measures. It's the self, you reporting out. Observational measures, normally those are done with behavioral measures. So they are a variable that's recorded by observing behaviors or physical traces of behaviors. So for example, you might have an IQ test and hey, they did this on these skills. They passed this skill with this score, right? Because it's an IQ test. Maybe you're measuring observable behaviors. How many times did a person smile? Maybe you have to record that. Maybe you're coding a person's care cost that are observable. Maybe you're measuring some sort of wealth or stress measures. Maybe how many teeth marks left on a pencil if somebody's stressed out or anxious, right? So there's all different sorts of observational measures, but they're normally some sort of behavioral measure that comes along with it. Physiological measures are inside the body, right? So it operationalizes a variable by recording biological data. right? So it could be things like brainwave activity, um, brain volumes for different things that are rated in any types of like CT scans, MRI scans, brain waves, sound waves, whatever it may be that you're listening to or however you're rating. Hormonal levels, eye movement, heart rate, all of these require the use of special equipment, but they would be classified under physiological measures. So scales of measurement, we have what we call categorical, quantitative, and then in the quantitative variables, you have three other types. They are ordinal, interval, and ratio. So the chart there gives you a good example and lays it all out for you. In the left is the type of variable. The middle are the characteristics of that variable. And then it gives you some real world examples. So if we're looking at operational variables, like I said, they're classified as either categorical or they're quantitative. Categorical variables are variables whose levels are categories, like men, women, dogs, cats, right? They're in categories. Quantitative are continuous variables. These are variables whose values can be recorded as meaningful numbers, right? So ordinal is like in order. It's ranked, right? Number one, best book, right? The number one book. Interval is equal intervals or distance between levels. So there's no true zero. Zero does not mean anything, but it's intervals. So think of intervals. And then finally, ratio. Ratio is equal intervals, and when the value of zero truly means none of the variables can be tested. So go ahead and look at the chart. It'll give you a different explanations for each of them, and I think it's pretty interesting. It gives you the real world examples, so that's kind of nice. So it ties it all together. Reliability of measurement, are the scores consistent? So if we're looking at construct validity has two different types of measures. So is it reliable? Yes, reliability, how consistent the results of the measure are. So construct validity and reliability. So is it valid? Does it have a validity? Does it measure the construct it is supposed to be measuring? Does the test that you're doing, the study that you're doing, the questionnaire that you're answering, is it measuring what it's supposed to be measuring? Is it valid? So there's three types of reliability when we're looking at construct validity, right? It is all three involved consistency. So there is what we call the test retest reliability, where the participant will get pretty much the same score each time they test. So if they test again and then they retest, they're still going to get the same or similar scores. That shows reliability, right? How consistent the results are. Inter-rater reliability, it's consistent scores no matter who is rating the variable. So if you have three different judges that are rating something for some sort of skill for whatever it may be, or researchers or whoever it is, whoever's rating should all get consistent scores no matter who the rater is, okay? Internal reliability is where the participant gives a consistent pattern of answers, no matter how the researchers phrase the questions. The consistent pattern is there, it doesn't change, and that's because it has internal reliability. So using scatter plots, you guys learned about scatter plots in the previous couple chapters. So when we're looking at a scatter plot, we're looking at the correlation between the coefficients, or what we call the R. So it's a single number that indicates the slope and spread of the dots on the scatter plot. So the slope direction can be either positive, like here, it slopes upward, or negative sloping. See here, you can see this, the scatter plots kind of go down, okay? And, or there can be no slope at all, like this one here, where the dots are kind of like all over the place. They don't really have a pattern, right? So that would be no slope. So scatter plots show the correlation and strength of the plots. So the spread of the plots closer together in a line shows a stronger correlation. So you'll see here that these are both positive sloping because they go upwards, but these dots tend to be closer together, which shows it has a stronger correlation than the dots over here. So the dots over here have a weaker correlation. They still is correlation. There's an upward slope there, but not as tightly put together as these ones. So the stronger they're together, the stronger the correlation. The further spread out they are, the weaker the correlation. So the R value below each scatter plot the correlation coefficient indicates the direction of the relationship and the strength of the relationship. So upward slope, and there's kind of spread out, but you could still make out the pattern. versus this one here to your right. Upward pattern, it's the positive slope, closer together, stronger strength of correlation between the two variables, X and Y. Okay, here another again, test, retest reliability, same types of things that we're looking at. To see if a scale has test and retest reliability, we test the same group of individuals twice, a few weeks or months apart. So in A, the scores on a personality trait such as extroversion should show a strong correlation, indicating that they stay consistent over time. So if you notice, they're scoring at the time 2 months later, and this was the first time they scored. So when you bring A over from one to the other or X to Y, you'll see that the correlation is where they plot things and they're pretty consistent. It shows that even though they tested the first time and 2 months later, the slope is still going up. And I did put a line in there in the middle for you guys so that you could see that it is consistent. Okay. If we're looking at B, some traits such as allergy symptoms are expected to have low test retest reliability because they are inconsistent over time. Because allergies come and go, right? You don't always have allergies. So it's not going to be the same, okay? It's not going to have that consistency over time, right? So we expect test and retest reliability to be low as allergy flare-ups don't stay the same over time, right? You don't have constantly allergies. So you can see how all the little plots are more spread out. There's really no pattern to them. They're just kind of there. So it's a lower consistency there. So a low R is a sign of low test or retest reliability if we are measuring something like extroversion or even intelligence. So it should supposedly stay the same over time. You don't really lose your intelligence. So that would then be a low sign of test retest reliability. Inter-rater reliability, like I said, it's two or more independent raters, but they get the same types of observations. So a positive strong inter-rater score would be around a 0.70, because remember, for us to have a good score, it should be positive 1 within the range of positive 1 to 0 or negative 1 right in there. So we can see here that you have an A and you have a B. So if you read down here below, the data on the points show the pattern. For letter A, marks observer ratings of happiness, and observer marks ratings of happiness. So if the data shows this pattern, it means Matt and Mark have good inter-rater reliability. They are rating almost consistent. Here's Mark's and here's Matt's ratings, and here's the participants that they're using, and they're rating about the same. If it does not have good inter-rater reliability, you'll see that the plots are kind of all over the place. So here Mark rates Jay way over here, but yet Peter rates Jackie up here. So they're very far apart, not as consistent with the plots. They're not in so much of a line as here. Here's the line for you here, and you can see that the plots aren't even lined up there. So that is low inter-rater reliability there. So if we're looking at inter-rater reliability, you'll see that here's an example of items that they put together on a survey, and they had people go through and answer certain questions, and then they tallied up answers, right? So this matrix shows the correlations among 5 items listed on a well-being scale. And they assess the internal reliability by computing the correlation of each item with every other item. To find the correlation between the 2 items, they locate where one item's column and another item's row intersect. So in this case, for the example, the correlation between item 1 and item 3 is 22. So you'll see that right there. You come across item 1 and then go down to item 3. I am satisfied in my life, 0.22. So you can see that items 1, 2, 3, and 5 correlate with one another, but item 4, the one about polka dots, does not correlate with any of the other items. You can see that there's no types of correlations going on here. It's just kind of over here by itself with a negative 0.01. The pattern suggests that item 4 is problematic, and this set of items is not internally reliable. So relevant measures that use multiple items of observation to get the same construct are what we call internal reliability. So we have different types of internal reliability. We have what we call the average inter-item correlation. So it's the mean of all the possible correlations computed between each item and the others. We also have the AIC of 0.15 to 0.50 means that the items go reasonably well together. So you can see here that most of the items, if we're looking at the example here, do fall within the range of 0.15 and 0.50. So those items do reasonably go well together, but then we have item 4 that does not. So we have cornbacks alpha, which is alpha or A coefficient, and it mathematically combines the AIC and the number of items to the scale. So the closer it is to 1.0 or positive 1, the better the internal reliability. A lot of the times researchers are looking for a 0.80 or higher when they're looking at self-reports for things like that, checking for reliability. So, and again, a summary of reliability concepts that's in your guys' textbook. It goes over the 3 different types, when are they needed, and how they can be evaluated. If you're reading about reliability in journals, this is from your guys' textbook. So it's the table shows the interreliability labeled as the coefficient alpha from each of these studies, as well as test and retest reliability for each, right? So here's your alpha coefficient, your test retest reliability, and your interval reliability and how often they did it. 2 weeks, 1 month, 10 weeks, so on. So the table does not presently rate inter-rater reliability because satisfaction with life is a self-report measure, and the inter-rater reliability is only for observational measures, behavioral measures. But based on the evidence in this table, we can conclude that the subjective well-being has acceptable internal reliability and acceptable test-retest reliability. So the coefficients here for most of these are above 80, which means the scale has a good internal reliability. There are high correlation efficiencies here as well at 0.83 for retesting 2 weeks apart, which means the scale also has good test and retest reliability. So if we're talking about validity of measurement, does it measure what it's intended to measure? We need to think about that kind of stuff. Measurements of validity of abstract concepts. How are we going to put that together so it can be something that can be measured? What's face validity and content validity? Does it look like a good measure? Criterion validity. Does it correlate with the key behaviors? Is the criteria there that you're measuring for? Convergent validity and discriminant validity. Does the pattern make sense? And then finally, relationship between reliability and validity. So here's a nice little graph that's put together for you guys, and it looks at the construct validity. So it is one of the 4 big validities, and it is supported by a variety of evidence. So if you go through and you look at construct validity, you have the other types here, but for this particular graph, we're focusing on construct validity and how construct validity works. And you would follow then the 2 different arrows that can take you to different places where it talks about face validity, it talks about content validity. If you come down here, it'll go over the 3 empirical ways to assess validity. It looks at things like criterion validity, convergent validity, and discriminant validity. So it's a pretty nifty little chart that I think you guys will find interesting and helpful. So if we're looking at face validity and content validity, like I said, does it look like a good measure? So face validity, it looks like what you want to measure. So face validity is a memory test, right? Okay, you have to memorize this list of words, right? Okay, yeah, it looks like what you want to measure. Is it a spelling test? Is it a math test? What is it? It has face validity. Content validity is the measure that contains all the parts that your theory says it should contain. So if you're doing an intelligence test, then obviously you're going to have questions on the intelligence test that are content that's related to intelligence. And in this case, it's a math problem that has multiple steps to it that uses both multiplication and addition to get the answer. So that's a little visual for you that I put together so you guys could visually see what we're talking about. Looking at criterion validity, does it correlate with key behaviors? Criterion validity refers to how well the results of a test or measure correlate with an outcome that it should be related. So in other words, does the test predict or align with real-world performance or established measurements? So you can see here, panel A, this scatter plot going upwards is positive, and it shows a strong correlation between sales aptitude test and sales figures. B does not. You can see that the plots are scattered over everywhere. So a criterion validity is the measure works in the real world and it shows whether your test is useful for predicting or matching outcomes. So here from your guys' textbook are also what we call known group evidence for criterion validity. So the known groups paradigm, or sometimes called the known groups validity, is a way of testing validity measures by comparing scores between groups that are already known to differ on construct behaviors. So depressed versus non-depressed, non-mild, moderate, and severe depression. How are we going to rate them? What are the psychiatrist ratings for those? So you can go ahead and take a look at these different types of histograms or bar graphs. What do you see? What are the scores measured and why it matters? Convergent validity is evidence that you measure that is related to other measures of the same construct. So if two tests are supposed to measure the same thing, their scores should be correlated. They should be convergent. For example, a new depression inventory has high convergent validity if its scores correlate strongly with the Beck depression inventory, which is an inventory that we can give in the field of psychology, especially if you're a therapist and you're wanting to assess somebody for depression. A new self-esteem scale should correlate with another established self-esteem questionnaire. So convergent means things should be related as they are related. So if we're looking at discriminant validity, aka divergent validity, it's evidence that you measure that is not too strongly related to measures of different related constructs. So it shows that the test is measuring something unique, but not just overlapping with anything else. So for example, a depression scale should not correlate strongly with a measure of physical fitness. A math test should not be highly correlated with a creativity test. Those two things don't really go together, right? So a discriminant is things that should not be related or intended to not be related. So your key point and takeaway for construct validity is content validity shows your measure overlaps where it should, and discriminant validity shows it doesn't overlap where it shouldn't. So both together help prove your test actually measures the construct of interest, not something else. So takeaway for this week's chapter, the validity of a measure is not the same as its reliability. A measure can be less valid than it is reliable, but it cannot be more valid than it is reliable. And reliability is necessary, but not sufficient for validity. I just want to remind you guys that you guys do have 2 assignments that are due this week. So you have your discussion post, which is to design a survey question. You will be using that later when it comes time for the midterm paper. So for the first shot at this, you're only going to create one simple survey question. You do need to figure out how you're going to collect responses from 15 participants. There are many ways that you could do that. You could ask family and friends. You could put together a little Google form, send it out to, certain people. There's different places you can create a survey question online that you can get people to answer. It really depends what you want to do there. So keep that in mind. I think that's a little interesting. You get to pick a topic that you want to do it on, some sort of a specific psychological behavioral topic. And then you guys do have your JASP assignment for this week. That's activity 2 for measurements and analysis in JASP. So what you're going to do is you're going to take your scores of the 15 people that you collected, and you're going to provide examples, and you're going to create a data set for your 15 participants. So the directions are all there as well in there. So you're going to take the data you collected from your survey question for this week, and you're going to run what we call a descriptive analysis of your answers using JASP. So if you need help with that, please show up for office hours this week or email me. I did put my email address down here. We can meet up at a different time via Zoom, and I can help you guys out with whatever you may need. So it's a lot of information to cover this week, but it's definitely good. Like I said, I hope you guys enjoy class. And if you have any questions, please reach out. See you later.